All right, so what we're going to take a look at right now is how to write a modular program using Raptor. Okay, and to show this, I'm going to do this particular exercise, the paint job estimator. This is actually from the Gaddis Programming Logic and Design book, third edition. This is at the end of chapter 3. All right, so the description of the problem says, a paint job estimator. A painting company has determined that for every 115 square feet of wall space, 1 gallon of paint and 8 hours of labor will be required. Okay, the company charges $20 per hour for labor. Design a modular program that asks the user to enter the square feet of the wall space to be painted and the price of the paint per gallon. So those are going to be our two input things. The program should display the following data: the number of gallons of paint required, the hours of labor required, the cost of the paint, the labor charges, and the total cost of the paint job. Okay, so there's several things that we have to calculate there. All right, so just real quick, I'm going to make a few notes. I'll just use Notepad. I'm going to list out some different variables that we're going to have to keep track of. I think this will help us here in a few minutes. So our input, what's our input going to be? We're going to ask the user to enter the square feet of wall space and the price of the paint per gallon. So we could have a couple of variables. Let's make a note here. This is input variables. Maybe something like wall space and maybe something price per gallon. Okay, those are going to be for input. And then variables to calculate see, we're going to need to know how many gallons are required. A variable for that. How many hours are required. The cost of paint. The labor charges. Well, let's call let's name it labor charge. The total cost of the paint job. All right, so that's all I can think of for now. They do give us a couple of pieces of information here. We could make those constants if we wanted to. So in Raptor, I don't know that you can really set something as a constant, but you can just create a variable for it and pretend like it's a constant. The idea with a constant is that it stays the same, but if we wanted to go back later, if for example, if the labor charge changed or something like that, we could just change this one thing and it would change everywhere it was used. So I might set up a couple of constants. That's a good way to do it and to make it more adaptable for the future. So it says for every 115 square feet of wall space, 1 gallon of paint and 8 hours of labor will be required. So what could I name that? For every 100. I don't know. Base size. I don't know. That's probably not a very good variable name, but let's go with that. And then the company charges $20 per hour for labor. So labor rate maybe 20. Okay. So those are some notes. I'm just gonna save those. Paint job notes. Okay, we'll come back to that. All right, so let's load up Raptor and see what we can do. All right, so here is Raptor. First of all, the first thing I should talk about here in Raptor is the difference between a subchart and what they call a procedure, I believe. So a subchart is basically an extension of a current flowchart you have going. So if you added a subchart to main, you would basically be in a separate tab, but it would basically just be an extension of main. It would be as if those statements in Raptor were actually inside of main there. So one thing that I really want you guys to learn about is this idea that a modular programming that you see in a lot of different programming languages, and they might call these things in different things in different languages, but for example in C++ it might be called a function. In another language it might be called a method or something like that. But the idea is that these are separate modules, and if you want to skip over to that module, you have to call that module, and if there's any variables or any data that module needs in order to do its job, you need to send those things in as parameters. So there's this concept of parameter passing that's really, really important for computer scientists to grasp. And so with a subchart, you don't have to mess with parameter passing or anything like that, because it's really not a separate module. It may look like it in here, but it's not. It's just kind of, it's not a module in the sense of what we're talking about here. So we want to add a procedure. We want to do some procedures, but you might notice when I right click on like the main procedure here, for example, or the main chart, I don't get an option for add procedure. And in order to do procedures, you have to switch modes in Raptor. So you go up to the pull down menu where it says mode, and you have to switch from novice to intermediate. So you have to be in intermediate mode in order to do procedures. Now when I right click on main, I can add a subchart and I can add a procedure. We're going to be doing procedures where you can pass parameters. Subcharts, I don't think you can pass parameters or anything like that, but procedures you can. Okay? So we'll do that here in a little bit. The first thing I'm going to do inside of main is I'm going to basically set up my variables. Okay? So all these variables that I listed on my notes, I'm going to set these up. So I'm going to have, let's do this base size and labor rate first. So these are just going to be a series of assignment statements. Oh, I got to save. All right, so I'm going to save this as paint job estimator. Okay. And I'm going to have a whole bunch of these. So I can just put in a whole bunch of boxes here. We can add more if we need more. So what were the constants? Base size and labor rate. Okay. Base size. Set base size to 115. So we're going to initialize it, and this kind of serves as a constant for us, even though it's really a variable. Set base size to 115, and labor rate was 20. Labor rate. Okay, so those are our kind of constants that are given to us. Now let's declare these other ones. Wall space and price per gallon. Wall space, I'm going to set that to 0. Just going to initialize most things to 0. And price per gallon, I'm using camel case notation here. That has kind of become standard as far as how you name your variables. So that's the, again, camel case notation is where you capitalize the first letter of every word starting with the second word. All right, so I've got wall space, price per gallon. Let's do these others. Gallons required, hours required. Set them all to 0. I have a cost of paint and labor charge. I need some more variables. Oh, why's that not working? Assignment. Labor charge. And then we have total cost. So I think that's all of them. If not, we can add more. Okay, so I've got all my variables declared and set up here inside of main, inside the main module, or the main chart here. Now I need to decide how I'm going to split this thing up into separate modules. Right, so good candidates for modules are on programs like this are usually maybe to have an input module, then maybe have a separate calculation module, and then a separate output module. Okay, so let's write an input module where we get these two things, pieces of input that we need: wall space and price per gallon. So yes, we could put all this stuff inside of the main chart here, but what we're supposed to write a modular program. So let's add a new procedure. So I'm going to right click on the main tab. So you go up here where it says main, you right click and you choose add procedure. Again, if you don't see add procedure, you need to change your mode from novice to intermediate. So add a procedure. When you add a procedure, now you get options for sending in parameters. I don't think you get that with SubCharts. So we put the procedure name, maybe something like get input would be a good name for this procedure. And then we list out the parameters that we want to send in. And we specify, is this for input or output or both? Right? So there's a concept of passing by value and passing by reference in a lot of programming languages. Basically, and so that's basically what this is dealing with. If you just pass for input here, you're basically passing by value. If you pass for input and output, you're basically passing by reference. So basically, if anything that you're sending in is going to change, if you're going to change the value or the contents of any of these variables that we're passing in as parameters, you need to pass by input and output. But if you're only using the value within there, you should just pass by input. So here's what we're going to do. So we need to pass in wall space. We need to pass that in for input and output because we're going to be inputting it. So we're going to be changing it. And we need to pass in price per gallon. Those are the two things that this module needs. So it's the name of the module is get input. We're passing in wall space and price per gallon for input and output. I forgot to change that. Input and output on both of those. Okay. And if I were to have missed that, I could go back and modify it and update it. Okay. So now I get a separate module up here. So I've got different tabs for the different modules, or in Raptor they're called procedures. So we got the main, and then you got get input. So get input, we're just going to put some statements to get the input. So this is going to be pretty short. So get an input statement, put it in there, get two of them. So in the first one, we're going to say something like enter the amount of wall space. I can't remember if I had to put that in quotes or not. I'll find out. And then we're going to store that into wall space. Yep. Yeah, you have to put in double quotes. So again, enter the amount of wall space. I just put a colon and a space there. Oh, actually, it comes up in a window, right? So I don't really need that. Enter the amount of wall space, and then it's going to store it into wall space. And the same thing here inside of double quotes. This was the price per gallon. Enter the price per gallon for the paint. And then store that into price per gallon, like that. Okay. So there you go. I think that's all that we need to do for that procedure as far as that goes. But when we run this, the procedure is not going to get done unless we call it. So we can run that. You can see it creates all of our variables and stores zeros or whatever we told it to store in there. But it didn't skip over to get input. And so in order to make it skip to get input, you have to put a call in there. So you notice up here on our symbols, we've got a call. So let's call get input. So I'm going to click call, and I'm going to put a call down here right after I've created my variables. And I'm back in the main module right now. So I can double click on the call, and here I'm going to call get input. So the way that you do this is you put the name of the module, get input, and then inside of parentheses you list the things that you're sending, but you don't put in out, you just put the name of the variable. So you just put wall space, comma, price per gallon, and then close parentheses like that. So get input, and then inside of parentheses, wall space, comma, price per gallon. And then click done. Again, that's what I typed in the smaller window there. And now let's try it and see what happens. So play, and it gets to that call, and it skips over to get input and asks me to type in the wall space. Oh gosh, I don't know. How about something like 400 square feet? And it asks me to type in the price per gallon. I'm going to say $15. Okay. And it stored those things. And you can notice back over here on our our variable monitor, it actually stored 415. Those are the things that I typed in. But if you were to have set up this get input module, I'll right click it and do modify procedure. If I hadn't have sent those in for output as well as input, back in main, it would not have remembered the 15 and 400. So just to show you what I was talking about, I put 500 this time and 17. So notice back in the main module, it did not remember the 500 and the 17 or whatever I typed in. So that's why you have to pass them in for input and output. And that's basically passing by reference. So there you go. All right, let's move on. So let's write another module to do our calculations. And looking back over here on our notes, how many things do we have to calculate? We have to calculate 1, 2, 3, 4, 5 different things. But in order to calculate those things, we also need to know these things. So that's 2 more things, so that's 7 things. And we might also have to have these things. So that's like 9 different variables or possible parameters. And if I remember correctly, when you add a procedure, at least in Raptor, you are limited to how many parameters that you can send in. So we can't send in 9. So we're going to have to split all these calculations up into 2 modules. So we'll have one module that does one thing, that does some of the calculations, and one that does some more of the calculations. So maybe, let's see here. So some of the calculations are related to the paint, and some of them are related to the labor charges and stuff like that. And there's a total cost too. We might just do that back in main or something. We'll see. So let's write one procedure or one module to calculate the paint stuff. All right. In fact, let's name it something like calc paint stuff. That works. So this will include the gallons required, the cost of paint. Yeah, gallons required and the cost of paint. But in order to calculate those things, we'll also have to send in the wall space and the price per gallon. And the base size. All right, so anything that's going to change, any of these things, we need to pass it in for input and output. We need to pass by reference. But anything that we just are going to use in order to calculate stuff, but we're not going to change, such as wall space, price per gallon, and base size, we can pass those in just as input, pass by value. So I'm going to list those things first. It doesn't matter what order that you're in, that you put them in, as long as you're consistent with it. So I'm going to send in wall space, price per gallon, and base size. And I'm going to send in those 3 things just for input. And then I'm going to send in gallons required for input and output because we're going to calculate that. And cost of paint. I'm going to send that in for input and output. And if there's anything else, we'll go back and add it. All right, so there's several things I'm sending in there. Okay. All right, now that we have our parameters going into our module here, our procedure, let's do some calculations. So the two main things that we're going to calculate here are the gallons required and the cost of the paint. In order to know the cost of the paint, we have to calculate the gallons required first. So let's do that first. So let's use an assignment statement. So the gallons required. So if you go back and look, we have this base size, whatever, I think that's what I named it, is of 115. For every 115 square feet of wall space, 1 gallon of paint is required. So we need to know the wall space, which we sent that in already. Okay, so it's the wall space divided by 115, or instead of 115 we use base size, and that should tell us how many gallons of paint are required. So let's see here. So set gallons required to wall space divided by base size, which is, will be 115 here. And I think that's it. So that will tell us the gallons required. And then once we know that, then we can calculate the cost of the paint. So let's put in another assignment statement right there. Set the cost of paint to, that will be the number of gallons required times the price per gallon. Gallons required times, that's an asterisk, price per gallon do we end up using everything that we sent in? Wall space, price per gallon, base size, yeah. Gallons required, and cost of paint, yeah. So we did need all those things. So those are the things that we needed to calculate that were related to the paint. So I'm going to save that. The name of that module was calc paint stuff. So let's call it. Go back to main, and then you go down to where you wanted to call it. We want to call it after we've gotten the input. So put a call down there and double click on it, and then we're going to call it. Calc paint stuff. And yeah, so you can all, if you see it down here in the list, you can double click on it. It'll fill in the rest of it, or at least the name there. Calc paint stuff, we're going to send in wall space. So the order, the parameter list has to be the same as what we had earlier. So make sure that you send in things in the correct order, in the same order. Price per gallon, base size, gallons required, what you're spelling, and cost of paint. 1, 2, 3, 4, 5 things. All right, so let's run it and see what happens. So I'll just say 500 square feet and maybe $17 per gallon. So and again, you can always slow it down with the slider up here if you want to see it, more in action. Gallons required 4.3478, and cost of paint is 73. Now technically you wouldn't be able to go to the hardware store and buy 4.3478 gallons of paint. You'd have to buy 5. So I can't remember if there's a there might be a function, we'll have to see, that does like a ceiling or a floor function that will round the number up. We'll check it out in a little bit. But let's go on. So that is count paint stuff. Let's do the same thing. Let's create another procedure to calculate the labor stuff. So right click on main and add procedure. Just curious, can you? Yeah, you can. Right click on main, add procedure. We are going to name this calc labor stuff. And we'll kind of set it up the same way we did calc paint stuff. So I'll send in, so we're going to be calculating, get our list back. We're going to be calculating hours required and labor charge. In order to do that, we need to know we actually need to know the base size and the labor rate and the wall space we're going to send in hours required and labor charge. So I think there was one more thing than the other thing. All right, so let's put the things that we're not going to change first. So there was wall space. So just send that for input. If we don't need price per gallon here, but we need base size, and we need labor rate. And then we're going to calculate hours required and labor charge. And hours required and labor charge we're sending in for input and output. So that one goes with that, that one goes with that. All right, so we still have 5 parameters there. All right, and make sure you save from time to time. So back over here in calc labor stuff, the first thing we need to calculate is the hours required. Okay, so how do we do this? Set hours required to this depends partly on on how big the wall space is, right? So back in the narrative, it says for every 115 square feet of wall space, that's our base size. One gallon of paint and 8 hours of labor will be required. Okay, so it takes 8 hours to do the base size. So how many if you take wall space and divide it by the base size, and multiply that times 8. Does that do it for us? We'll do the division first, which is what we want. Wall space divided by base size. I think that's it. We'll come back and look at it later and make sure it looks reasonable. And then once we know the hours required, we multiply that times the labor rate. To get the labor charge. So set labor charge to hours required times, we have a variable for labor rate. Labor rate. So figure out the hours required and then figure out the labor charged. Labor charge. I think we used everything. Wall space, base size, labor rate, hours required, labor charge. Okay, so that's calc labor stuff. Now let's go back to main and call it. So again, we need to call this, we'll call this after calc paint stuff. And we double click on that and we put calc labor stuff. We send in wall space, base size, labor rate, hours required, and labor charge. Close parentheses. So that's what it looks like. Calc labor stuff. And we're sending in wall space, base size, labor rate, hours required, labor charge. The parameter list goes in parentheses. All right, save it and let's run it and see what happens. Amount of wall space, I was putting in 500, and price per gallon, I was putting in $17. So it skipped over, did the two modules, and let's see, hours required, 34.78. Is that right? Yeah, I think that's right. So if, no. Yeah. So if it takes, for 115 square feet, it takes 8 hours. So for 500 square feet, it would take about 34 hours. that sounds right. And then the labor charge, wow, I should be a painter. $695. Okay, and then we have the cost of paint, $73. So let's add those two together to get the total cost. And since it's just one calculation, I'll just do it down here in main. I'll do it underneath here. Set total cost to cost of paint plus labor charge. Total cost $769. Yeah, looks good. Oh, okay. So we've got our modules. Yes, and we can see our results over here on the monitor, on the variable monitor window, but technically we're not outputting these things yet. So we need to write a module that will output these results, or at least some of the results. So it says the program should display, and it lists out the things. So there's 1, 2, 3, 4, 5 things that they ask us to display. So let's write a separate module for that. So I'm going to right click on main, add a procedure. I'm going to name this something like output results. And when I say output the results, we're going to output them to the master console. Right? So we're not going to be changing any of these parameters. We're just going to be outputting them. So we can just pass them all by value. In other words, just leave this as input. We don't have to check the output. So the things that we're going to output are the number of gallons required. That was gallons required. Make sure you're getting your variable names right. And the hours of labor required. Hours required. The cost of the paint. That was cost of paint. The labor charges, which was labor charge. And the total cost of the paint job, which is total cost. Okay, and so now this is just going to be a series of output statements, and we're going to output these to the master console. So get you an output statement, and let's just put several in there. How many things were there? 5. There you go. So we'll do each one. We can do them in a different order if we want to. So I'll put a message, number of gallons of paint required, maybe a colon. Remember to put that in double quotes. And then if you want to add the variable, we say plus, then the variable name, gallons required, like that. And then make sure this is checked, end of current line. And then all these are going to work the same way. Output, I'll do them in the same order. Hours of labor required, colon, followed by hours required. Then cost of paint, colon, and maybe even a $sign there, followed by the variable cost of paint. And then labor charges. Labor charges. Let's say labor charge. Colon $sign plus labor charge. And then the last thing, total cost plus total cost. All right. And we'll come back and add things if we need to make it look a little prettier. Go back to main, let's call that. Again, it doesn't get done until we call it, so put in a call down there. And we're gonna call it output results. And we'll send in our parameters. Gallons required, hours required, cost of paint, labor charge, total cost. And there it is down there. So let's see what happens. So we type in 500 or whatever the wall space is, and there's the price per gallon. It calculates it, and then outputs our results to the console. So the number of gallons required is that, number of labor charges, or whatever, so forth. All right, looks good, but let's see if we can clear the console window. So back over here in the output results, I think the way we do this, I think we put a call in there at the very beginning. And I think we just say clear. Oh, clear console. Maybe that's it. Clear console, open and close parentheses. Clear console, clear underscore console, open and close parentheses. Let's see what that does. Yeah, so it clears the console, so we don't get the results from the previous run up there. Okay, so a couple of other things. I said I was going to go in and see if there's a way to round up, like for the gallons of paint. So let's take a quick look here in the help file. Help, general help. And let's see if there is a ceiling function. That would probably be in math. No. Hey, there we go. Ceiling. There's a ceiling function. Ceiling returns the lowest integer value greater than or equal to the provided argument. For example, if you put in 15.9, ceiling is 16, so it'll round up. So that makes sense for this particular application. If you want it to round up on the paint gallons, because again, you're not going to be able to go to the hardware store and give me half a gallon of paint, or I mean, unless they make half a gallon. But you can't say like, give me 0.67 gallons of paint or something like that. You're going to have to buy the whole gallon, right? So let's see if we can get that to work. Ceiling. So where should we put that? Maybe in calc paint stuff. Cost of paint, gallons required. So we would want to do it here. So we could do it in the calculation, or we could do it right after. Let's see if we can. So here's how you would do that. I think you say set gallons required to ceiling, and then what we had in there before, wall space divided by base size. So it'll do this calculation and then round it up to the nearest whole number. So let's see if that works. So what were we getting before on the gallons required? 4.34. So let's see if we get 5 now. Yeah, so gallons of paint, gallons required is 5. So there you go. So Raptor does have some built-in functions and things like that. So, but unfortunately that added to our cost. What else? Number of gallons required is 5. I'm just going to leave the hours of labor as a decimal thing. Cost of paint, $85, labor charge. All right, I think that's it. So there you go. There was a lot more on this example, but we showed how to write a program in Raptor using different modules, and how to pass in parameters, and the difference between passing parameters by value and by reference, or input and output, right? So we saw that. And we even threw in a built-in function like the ceiling function, and we saw how to call modules as well. So hopefully that will help you understand the concept of modular programming there.